This doesn't look like one of the greatest engineering inventions ever built. It is just a concrete channel, yet this quiet structure has been protecting hydroelectric power station for nearly 90 years. Every second it removes sand, gravels and tiny rock particles before they can destroy equipment worth millions. And today we have a rare opportunity to show you exactly how it works. Normally, everything you are about to see is hidden beneath rushing water. The engineering is completely invisible, but today is different. One of these hydroelectric power stations has reached the end of its service life. The old powerhouse has been completely dismantled. The turbines are gone, the generators are gone, and even the powerhouse building has disappeared. Engineers have excavated the entire site, where a brand new powerhouse will soon be built using modern equipment. With the station shut down, its intake and sediment removal basins have been completely drained. For the first time in decades, every detail is exposed. Just a short distance away, another powerhouse is still operating. Its intake is full of water, doing exactly what it was designed to do. That gives us a unique opportunity. Today, we will compare the same engineering system in two completely different conditions, one empty, one operating. By the end of this video, you will understand exactly what happens beneath the surface every single second. But to understand why this structure exists, we need to go back almost a century. Long before this power station existed, engineers built a large canal system for irrigation. The goal wasn't electricity, it was agriculture. The canal carried enormous quantities of water across farmland, transforming dry land into productive fields. But once all that water was flowing every second, engineers realized something. The water wasn't just useful for farming, it also contained an enormous amount of energy. So they built a hydroelectric power station besides the canal. Instead of wasting the water after generating electricity, they allowed it to continue downstream, where another powerhouse extracted even more energy before the water returned to the irrigation system. One flow of water, two power stations, multiple benefits. It was an elegant design, but there was one problem. Every second, the canal also carried sand, gravel, silt, and countless tiny rock particles. Individually, they look harmless, but inside a turbine operating under high pressure, those tiny particles become microscopic cutting tools. Hour after hour, day after day, they slowly erode the steel surface, wicket gates and guide vanes, then runner blades, until efficiency drops and expensive repairs become unavoidable. So before the water could even ever reach the turbine, engineers had to remove the sediments. And the solution begins right here, this empty concrete basin. At first glance, it looked like an ordinary channel, but watch carefully upstream. The channel is relatively narrow, then suddenly it becomes much wider. That single chain is the secret. The same amount of water suddenly has much more space. As a result, its velocity decreases dramatically, and when the water slows down, gravity finally gets a chance to work. The heavier sand particles can no longer remain suspended. They began settling towards the floor, and engineers didn't stop there. Look at the floor itself. It isn't flat, it shapes into a gentle rising ramp. The shape reduces turbulence and helps spread the flow evenly across the basin. Calmer water means more sediment settles instead of remaining suspended. Now look even closer. Notice these long opening running along the bottom. These are the heart of the entire system. As the sediment settles, it falls into these slots. Instead of continuing towards the turbine, it enters the underground bypass channel hidden beneath the basin. From there, the sediment is carried away and safely discharged back into the canal farther downstream. The sand continues its journey. The clean water continues towards the powerhouse. It sounds simple, but the beauty lies in the fact that gravity does almost all the work. No complicated machinery, no high speed separator, just intelligent hydraulic engineering. Now let's compare that with the operating station. Everything we just explained is happening here right now. The only difference is you can't see it. Beneath this seemingly calm water, tons of sediments are quietly settling into the bottom chamber. Every second, every minute, every day. While the heavier particles sink, the cleaner water remains above. That's the water. That is the water that moves towards the intake. Before entering the powerhouse, it passes through trash rack. These steel bars stop floating debris like branches, leaves, and other large objects from entering the system. Beyond the trash rack, the water enters massive steel pipeline. These pipes carry it downhill under pressure until it reaches the turbine. There, the water energy is finally converted into electricity. By the time it reaches the turbine, most of the damaging sediment has already been removed, and that dramatically increased the life of the equipment. What's fascinating is that while turbine, generator, and electrical systems have changed enormously over the decade, this basic sediment removal principle has barely changed at all. The old powerhouse may have reached the end of its life. The turbine served for decades before being dismantled. Its generator have been removed. Its building no longer exists. Today, engineers are constructing an entirely new powerhouse on the same site. The machinery will be modern, more efficient, more stable, capable of producing more electricity from the same flow of water. But notice what wasn't demolished. This intake, this sediment removal basin, this water conveyance system, because good hydraulic engineering doesn't become obsolete simply because new turbines are installed. The machinery may change, the generator may improve, control system may become digital, but the physics remain exactly the same. Water still slows when the channel widens, gravity still pulls heavy particles downwards, sediment still settles, and clean water still flows towards the turbine. Nearly 90 years after engineers first perfected this concept, the same principle continues protecting the next generation of hydroelectric equipment. Sometimes the most impressive engineering isn't the loudest, it isn't the biggest turbine or the most powerful generator. It's quite concrete basin that has been doing its job day after day for generation, because the greatest engineering solution aren't remembered for being complicated. They are remembered because they keep working.